The idea behind these videos is to take you to the journey of elementary statistics. Okay, so this is the basic requirements that typically a person meeting statistics for the first time will have. Okay, that's why we call it elementary statistics. Okay, but I would like to do it a little bit differently. It's not the usual go to the topics, exercises. I'd like to do it by building a story. Here's what I mean. So I have this fictitious set of data, which is about a school, a small school, all right, where you have a sample of 50 students, student 1 up to student 50. A sample of 50 students. They are between 15 and 16 and 13 years of age, male and female, and there are 3 classes. And there is this data on their performance in a mock examination. Okay, it's not the real examination, but a mock examination. And we have their performance in maths, English, and science, and their final mark, which is the average of these 3. Then we also have last year's final mark, but this is on these particular students, but this is the last year final mark as an average of their marks in maths, English, and science for last year. Now, the idea is this. Okay, I have this data set, but how can the tools of statistics give me important information? All right, such that I can make some interesting predictions, perhaps. All right, now let's say that you are a data scientist or a statistician or even a teacher, and you get a call from your principal, and the principal, he or she, has some questions for you. And if I have prepared these questions, all right, let's say that you have a meeting with your principal, as I said, and the principal starts coming out with these questions, right? For example, can we get a picture to understand the performance? All right, how are you know what they say, a picture speaks 1,000 words, right? So just by looking at a set of numbers, you'll get nothing. Can we start looking at some pictures? And through this question, we will look at how to construct histograms and how to construct box plots. All right. Even though I am very much Excel driven, but this course is not trying to show you how to do them with Excel. That will be a course for another time. All right. So I'm going to do them in preparation for a student who's going to face an exam, and the student has to do them pen and paper in an exam. Okay. So how do you construct a histogram and the box plots? And a second question would be, how spread out is the data? All right. As a teacher myself, I know from first-hand experience that if I go in a class and the data is very much spread out, all right, if I have students who are extremely well in the subject and others who are barely getting a 10-15%, I know that I'm going to have quite a difficult year. But if I know that my students are bunched up, everyone getting between 40 to 50-60%, I know that I'm going to have a much easier year. Okay, but this applies to all kinds of situations. Finance comes to mind. In finance, if your profits are very much spread out, okay, on 1 year you're making $1 million, on the next year you're losing 2 million. You know, there is a lot of uncertainty. So measuring spread and measuring the averages or a mean, I'll tell you later on what the difference is very much important. And in this hypothetical situation, the principal might ask you, how spread out is our data? What is the mean for each subject? And how spread out is my data compared to that mean? Those are very important questions. All right. We could also look at, for example, spread when it comes to males and females. Are females marks for female students more spread out than the male marks? All right, we'll see how to do that. Then we will ask some important questions on probability. All right, so let's say you pick a student at random. What is the probability that the student is going to get a distinction? All right, let's say that the principal is marketing the school as, okay, I'm going to invent here, it's a fictitious scenario, but let's say that in one of the marketing campaigns, the principal claimed that this school gives you, I'm going to invent, a 50% chance of getting a distinction. in your annual exams. All right? Well, what is the probability? What is the real probability that the student gets a distinction? What is the probability that the student fails, for example, in science, right? How can we do that? Well, we need to introduce the normal distribution and the famous Z formula. We'll see what it is. Then we need to understand that in real life, you don't usually get the population data. We usually get sample data. So we have to understand a sample distribution. What's the difference between a sample distribution and the population distribution? Okay, and then from there we'll see how to calculate sample size. For example, you're doing your thesis, and this question always comes up: how much questionnaires do I need to distribute? How many responses do I need? All right. From these formulas, we will derive a sample size formula. Okay. Moving on, we're still in the meeting with our fictitious principal on our fictitious school. The principal can then ask you, look, if I had to find the range of possible values, okay? Because remember, we are dealing, let me go back to the data. I am dealing here with a sample, student 1 to student 50. The school might have 200 students, 1,000 students. Well, we said it's a small school, so let's say it has 200 students, okay? And we are dealing here with only 50 out of these 200. So it makes sense to ask that if I have information on the sample of 50, can I get a range of possible values for the population? Let me give you an example. Let's say that we calculate that the average mark for the final exam is 50% from the sample. Can I get a range of possible values for the entire school? For example, okay, we say that the mean final mark will be between 45 and 55, right? Now, that's really valuable information. And remember, we're still working with a sample, okay? And then we'll see what happens if, for example, the sample is small. Here we have a sample of 50, which is not terrible. The cutoff point is usually 30. What happens if you have a smaller sample than 30? All right? And what happens also if you don't have key information about the population, such as standard deviation, which we'll deal with later on, all right? Then we will have to use a close cousin, I would say, to the normal distribution, which is the t-distribution. We will see how to use it, and more importantly, when to use it, okay? Next, the principal presses on. The school, in one of its marketing campaigns, is claiming that with the school program, the average overall is 55. Is this the school really delivering? Are we really getting a final average of 55? All right. You might tell me, okay, take the sample, calculate the average. The answer is no. Because remember, this is a sample of 50. What if there are 300 students in the school, 400 students in the school? All right. So the question is this: can from the sample I get enough information to make this claim that our average final grade is 55 on the whole school, on the population? All right. We will see that to answer that question, we will have to perform what is known as a t-test. All right. Actually, from this point onwards in my course, I will assume that we are only dealing with samples and key information about the population is missing, because that's very realistic. All right. So we will switch on to the t-distribution, not the normal distribution. If you don't know what this means at this point in time, don't worry. It will become clear by video 4 or video 5. Next. Key question, very important question. Are my students improving? All right. Are the teachers delivering? Are our programs updated with regards to educational developments? All right. So here we have to compare the previous year marks, which I remind you we have here. If I go back, I have the last year's final mark. So I have the last year final marks, this year's final marks, and we'll see if there is an improvement. Okay. And it's not just simply a question of comparing these two, because as I said, and I'm going to keep repeating this is a sample. Okay. So we will have to put ourselves in a position to make a claim on the entire school based on a sample. And for that, we will have what is called the paired sample t-test. The paired sample t-test, okay, which basically assumes that you're dealing with the same sample. This is the classical before and after test. All right, a classical example that comes to mind is you take a sample of people before they start a nutrition program or an exercise program. You take the same sample after the nutrition or exercise program and see if they have lost weight. All right, it's a perfect example for such a situation. But we're dealing with marks. Moving on, the principal would like to know if there is a difference in the average grade, for example, between maths and science, or between boys and girls, if there is a difference. All right. Notice something very important. We're only taking them in pairs here. Difference between two means. All right, difference between two means. Later on, as I'm going to tell you in a few minutes in this video, we will have a case where we're going to have 3 different means to compare, or 4 or 5 different means to compare. All right, but up to this point, we are only dealing in pairs. And to do such a comparison, we're going to have to look at difference of means. All right, we'll talk about pooled variances and that big ugly formula that we're going to see later on. But it's fine. I mean, it's nothing. It's not rocket science, okay? Moving on. Why stop at means? Can we talk about proportions? Is there a difference in proportion of students who pass English, for example, versus the proportion of students who pass science? Can we say there is a meaningful statistical difference in the proportion? All right. Statistics gives us a very powerful tool. It's called the difference in proportions. All right, we will see how to apply that later on. Moving on. What about prediction? Notice so far, we're only talking about differences. We're only talking about creating a range of values, our confidence interval. All right. We're only talking about probabilities, but we've never talked about predictions. Remember, my data set is a mock exam data sets. And you all know what a mock exam is. If you have the exam in June, usually teachers give you a mock in April. All right, just to show you, just to give you a snapshot of where you are at this point in time. But ideally, the principal would like to make a prediction. Can we predict the overall final mark? All right, and based on, for example, last year's average mark, based on their age, based on the mock exam, for example. All right. And also, is there some form of linear relationship? Can we say, for example, that the older you are, the better your performance? Can we say that the better your average mark last year, the better your performance will be this year? All right. So basically, in a nutshell, we are dealing with correlation and regression. All right. Very important, and I'll show you how not to, because these have big formulas, okay? So what I'm really concerned with is what they mean, what the answers mean, and how to really understand if your answers make sense, if they have statistical significance, okay? Moving on. This is a big one, all right? Usually 9 out of 10 exams and 9 out of 10 thesis, whatever, will have a question like this. Is there association? All right. Is there association, for example, between being in a different class and your performance? Or let me put it differently. Is your performance dependent on which class you're going to be in, or independent? It doesn't matter if you're in class 1, class 2, class 3. Remember, we had data on that. Every student is either in class 3, class 2, or class 1. All right, so basically we're asking, the principal is asking, listen, does it make a difference in which class you're in? Because if there is association between the class you're in and your performance, then maybe we might have a look at our teachers. Maybe teachers are performing differently, all right? Or maybe there are some students in that class that are bothering the others. They are misbehaving. And they are dragging down the performance of everyone, right? So these are important questions to ask. All right, to do that, we're going to perform the chi-squared test for association, right? Finally, and I have already alluded to this, is there a difference in means? But not between pairs of means, like for example, boys and girls or maths and English, but when we have situations of more than two comparisons, maths, English, and science, class 1, class 2, class 3, all right, etc., etc. So when we have more than two means and we want to check if there is a statistical difference between these means, we cannot use the t-test because that's only for pairs, but we have to look at ANOVA. So basically, ANOVA is like a t-test for pairs, but you're doing it with more than a pair when you have more than two pairs for comparison. Okay, so in a nutshell, by answering these 11 questions that the principal is posing, we will go through the entire elementary statistics syllabus. Okay? By no means am I claiming that this is a complete course, not at all. All right? I'm not going into any proofs, I'm not going into any elaborate mathematical derivations or even how to do them on an Excel. And of course, there are many more statistical tests that we will not be covering here. So this basically deals with something that, for example, an MBA student would find in his Introduction to Statistics, or a Bachelor of Commerce student would find in his quantitative analysis, or basically an introduction to what a psychology student might need in his or her thesis, or a pharmaceutical student. Okay, so as I said, there's a very basic introduction, and it's just the first step into the world of statistics. Okay, just as a final reminder, every video will be around 10 minutes. That's why this series is called Stats in 10. All right, and every lesson is a bite-sized principle building towards these 11 questions. Okay, in the next video, which is video number 1, I am going to start with pictures, histogram, and box plots, and understand how that help us make sense of the data.